Good evening, ladies and gentlemen. My name is Labib Shawar. I'm a master's by research student from the School of Electrical Engineering. My supervisor is Dr. Kumaresan, and the title of my thesis is Autonomous Anomaly Detection System for Electric Motors. Electric motors are used in every corner of modern industries. They can be found in robot arms, conveyor belts, you name it. As a result of continuous usage from companies, electric motors may develop a lot of issues as highlighted in figure 2. If these issues are not tackled on time, they can cause motors to degrade, which can lead to production downtime, machine breakdown, and financial losses. To overcome these problems, companies are now investing in predictive maintenance systems for electric motors. Now, many of these predictive maintenance systems have been proposed so far. However, they all suffer from certain issues. Most of them were built for tackling only a certain type of motor issue, whereas various issues may occur in a motor. Furthermore, these are supervised systems which are reliant on users for collecting and annotating the data manually. This can be really time consuming and will also require a lot of manpower to implement these systems. That's where my proposal comes in. I'm presenting a completely unsupervised system for detecting abnormalities in motors. So over here, as shown in figure 1, the users simply have to connect the current and vibration sensors to the electric motor, and the sensors will be interfaced with a computer which will autonomously collect the data and compile them for a certain amount of time, a week for example. And the system will use the collected data to train an LSTM autoencoder model. Once the model has been trained, it will be deployed online to look for anomalies. If the model detects data trends that deviate from the normal pattern, it will classify them as anomalies. So the user can monitor the condition of the motor through a web user interface as shown in figure 1, and also through a PC user interface. And if the rate of anomalies keeps increasing, the system will send an SMS notification to the user asking the user to check the motor. So this is a system which is really easy to implement, and the user can access the system through the PC user interface as shown in figure 3. I have tested the system by deploying it on an experimental setup which I built by myself. I used a stepper motor for this, and so far it has worked quite well. It has been able to detect anomalies perfectly and accurately. So this is a system which is really easy to implement, and it has a lot of potential in the manufacturing industry where electric motors are widely used. So that is all from me, and thank you for your time.